This video is going to be a trig review where we review the basic trigonometric functions. First, we'll start with a right triangle. Typically, at least one of the remaining angles is given. Using this angle, we can label the sides of our triangle. The hypotenuse is the largest side directly across from the 90-degree angle. The other two sides are labeled according to their position relative to the acute angle given. One side will be opposite of the angle and the other will be adjacent, forming the corner that makes the angle. Notice that if the other acute angle were given, it would change which side is opposite and which is adjacent. If we know all the angles of the triangle, we must choose an angle and be careful to keep track of which angle we use and how we label the sides. Now we can look at our basic trigonometric functions, which relate an angle to a ratio of the sides. The way we remember the definitions of these trig functions is with a mnemonic SOH CAH TOA. The S, C, and T represent sine, cosine, and tangent functions. O, A, and H represent the three sides of the triangle: opposite, adjacent, and hypotenuse. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. There are three other trig functions that represent the reciprocal or flipped version of these ratios. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Sometimes it's tempting to think secant goes with sine and cosecant goes with cosine, but this is incorrect. Instead, think of each pair having one function that starts with the prefix co. Tangent and cotangent obviously go together. Cosine already begins with co, so its reciprocal must be secant, leaving the reciprocal of sine as cosecant. It is important to note that these are not the same as inverse trig functions. This is very confusing because inverse trig functions are written with an exponent of -1, which usually means to take the reciprocal. Inverse functions will always either have a -1 exponent or they will be written with a prefix arc, such as arcsine or arctangent. Many calculators do not have buttons for secant, cosecant, and cotangent functions, but do have inverse sine, cosine, and tangent functions. If you need to calculate secant, for example, you should do this by calculating 1 divided by the cosine of your angle. A good thing to know about all functions is what you expect to put in the function as an input and what you expect to get out as an output. All of the 6 basic trig functions take in angles, either in radians or degrees, and output a number. That number is the ratio of the two sides from the definitions. Inverse trig functions, the ones with arc in front, undo the basic trig functions. Therefore, they take in numbers and output angles, the exact opposite or inverse of regular trigonometric functions. Keep in mind you may need to be aware of the valid domain of inputs that go into a trig function and the valid range of outputs. Some functions, such as tangent, go to infinity for certain inputs. From the definitions of these functions, we get equations, each having 3 variables. We are usually given 2 of the 3 and need to find the other. Here are a few example problems for practice. Feel free to pause and try these before we go through them. For the first triangle, we're given 2 sides and we're asked to find tangent and cotangent of the angle theta. We're sometimes tempted to think that we cannot calculate the tangent or cotangent of an angle without first finding that angle. However, remember trig functions are defined as ratios. We have been given the opposite and adjacent sides relative to the angle theta, and these are the ratios we need to find tangent and cotangent. Tangent of theta is opposite over adjacent, or 25 divided by 40, which reduces to 5 over 8. And you could write this as a decimal if you wanted. We can find cotangent in the same way by taking adjacent over opposite, but since we already have tangent of theta, it's easier to just take the reciprocal and get 8 over 5. Now if we're asked to find the angle theta, we could use either of these trig functions and solve using their inverses. Inverse tangent of 5 over 8 gives the same as inverse cotangent of 8 over 5, which is 32 degrees. For the next triangle, we're given one side and an angle and are asked to find the hypotenuse or longest side. Based on the angle given, the side that we have is the adjacent side. Therefore, we want to choose a trig function that has a ratio with the adjacent side that we know and the hypotenuse which we're looking for. These trig functions will be cosine and its reciprocal secant. Cosine is adjacent over hypotenuse, so we can solve by multiplying by h and dividing by cosine. Plugging in 18 for a and 35 degrees for theta, we get 22 for the length of the hypotenuse. If you need to write out all of the steps of algebra, notice that using secant would have been easier. Since h was already on top, Here we just need to move A over and plug in, getting the same result. For the final triangle, we're again given a side and angle and asked to find the other side. The side we're given is across from the 90-degree angle and is the longest, so it is the hypotenuse. The side O that we're looking for is opposite of our angle. So the trig function that contains a ratio with both the opposite side and hypotenuse is sine, which is opposite over hypotenuse. Solving for O by multiplying by h and plugging in 33 and 70 degrees, we find the opposite side is 31. Now we want to find the remaining side. We could use a trig function, but since these are right triangles, we could also use the Pythagorean theorem, a squared plus b squared equals c squared. In terms of our sides, this can be written as the opposite squared plus adjacent squared equal to the hypotenuse squared. Solving for the remaining adjacent side, we take the square root of the hypotenuse squared minus the opposite side squared. Be sure to perform the square, square root, and subtraction in the correct order, and doing this gives the adjacent side of 11.3. A good strategy for solving any problem with a right triangle is to quickly try and solve for all the sides and all angles as soon as possible. Then if you're asked to find any ratios or trig functions, you can use the most convenient function available to you. So that's it for this video, and I'll see you in the next one.